Two fundamental objects in geometry are points and vectors. Essentially, a point is a location in space. We represent a point visually as a dot, and given a coordinate system, we can represent a point by its coordinates in that system. For example, in two-dimensional space, the standard coordinate system is the Cartesian coordinate system. We represent a point in this system as an ordered pair of coordinates, first the x-coordinate, then the y-coordinate. So this point, located 2 units to the right of the origin, and 1 unit below the origin, would be represented as 2 minus 1. In 3 dimensions, we can represent a point in a similar way as a triple of coordinates. First its x-coordinate, then its y-coordinate, and then its z-coordinate. In contrast to a point, a vector is an object representing a change in position. In Euclidean space, a vector can be thought of as an arrow connecting 2 points. The important properties of a vector in Euclidean space are its magnitude, that is, the length of the arrow, and its direction. Given a coordinate system, we can numerically represent a vector by the amount of change it represents in each coordinate direction. For example, this vector moves right by 2 units, so we would give it an x-coordinate of 2. Since it moves up by 4 units, we give it a y-coordinate of 4. Notice that I write a vector's coordinate representation differently than I do a point's. I will usually write a vector as a column surrounded by square brackets, while I will write a point as a list of coordinates surrounded by parentheses. One major difference between a point and a vector is that a vector does not have a fixed location. If I draw the same arrow starting at a different point, it will still be equal to the first arrow. This is an important distinction. 2 vectors are equal if they represent the same amount of change in each direction, while 2 points are equal only if they are located in the same place. Despite this difference, while studying linear algebra, we usually conflate the notion of a point and a vector in the following way. Given a coordinate system, the point P is associated with the vector obtained by starting at the origin and ending at the point P. While this is usually a useful mental shortcut, it is sometimes helpful to remember the difference between the two concepts.